Hello, everyone. Can everyone at the back hear me? Great, perfect. Thank you for joining DataCon LA 2022. We're really happy to be back in person. My name is Maud Limban. I have Viva here. We'll be hosting and co-hosting this session. Before we start, please try to silence your phone till the end of the session. If you have any questions, we'll take them at the end of the presentation, so don't hesitate to raise your hand then. This session is currently being streamed on Zoom. Let me see if I can slideshow. Okay. And will be available, recorded and will be available online in a few weeks. So our first guest is Brandon Wong. He will be talking about demystifying the art of business intelligence and data analytics, which is under the BI reporting business use case track. Brandon is a lead software engineer at Academy of Motion Picture Arts and Sciences, which means he's responsible for everything from software design to data analytics to infrastructure. He has an education background in business analytics and finance. It was when he began working at Northrop Grumman that he decided to officially turn to computer science full-time. Approximately 8 years, 12 programming languages, 18 hackathons, and over 10,000 GitHub comments later, he has done software development in the following industries: real estate, aerospace, financial software, internet marketing, and currently film and entertainment. It's one of his true passions, in addition to working with technology, is teaching, inspiring, and leading others who are interested in pursuing career in tech-related fields. Without further ado, I'll hand this over to Brandon. Brandon, thank you.
Thank you, Maddie, for the wonderful introduction. Good morning, everyone, and thank you for choosing this track. I appreciate your time, and thank you to DataCon LA for having me again to speak. So, as you said, this is the Demystifying the Art of Business Intelligence and Data Analytics topic. And let me minimize this real quickly. Right. And I'm Brandon Wong, and I'm a lead software engineer at AMPAS, which is the short for Academy of Motion Picture Arts and Sciences. And you may also know us for putting on the Oscars every year, which is the award ceremony for film entertainment and things like that. So if you have any questions at the end, we can talk about the projects that I work on and things of that nature. So what do I do as a software developer? I mean, this is probably like my favorite image, kind of what my coworkers think I do, what my mom thinks I do, my boss, society, what I think I do, and then what I actually do. So definitely coding is a process. It's a love-hate relationship sometimes, a lot of screaming, but at the end of the day, we're trying to move forward and expedite and grow and develop new emerging technologies. So it's definitely a problem solver's world, and this world rewards problem solvers. So I was kind of thinking about what I would talk about today, knowing that I only have 40 minutes to kind of provide some value to you. And it's kind of in the morning, so you've probably just had your caffeine or breakfast. So I was thinking there won't be much live code or anything too technical, but it's mostly just laying down the foundations to get you guys ready for the future talks and other speakers we have today. Loving the process. These are also my two favorite memes. Not stressful at all, and it works why it doesn't work well. So regarding the stack that I work with, particularly, I've been using Microsoft products for about 8 years now, and so I'm very comfortable with Azure's and Dynamics and SQL Server. So at the Academy, we also use this backend with a CRM SQL Server backend with Management Studio as your middleware, and then you're feeding up to Visual Studio, Power BI, or Report Builder. So then you host those reports on a server and can be readily accessible to all your entire organization. There are other stacks as well, like Tableau, Salesforce, and many others that you use, but I think this is, since Microsoft is so powerful, this is one of the more popular ones. So a little bit of what we're going to go over today, the agenda. So introduction, a brief history of big data, where did it all come from, data scientist versus data analyst, the 4 parts of the BI reporting lifecycle, tips and tricks, and then a short Q&A at the end. All good? So a brief history of big data. Where did it all start? Why do we have it now? You probably already know this, but I'll cover it again. In 1999, we had emerging static websites such as Google, Yahoo, which are now billion-dollar companies. And they don't look like billion-dollar companies now, but some doing better than others. But this is how it started. And it was mainly focused towards providing value to the consumer. As you can see, there's not much cosmetic styling here. It's very plain. But as we start moving forward and technology starts getting better, it becomes what can the user do for us? So a small timeline of how these static websites and emerging technologies sort of became. Well, we started with the internet, the World Wide Web, Web 2.0 sites, relational database, SQL, NoSQL, and the ability to store data in a smaller form factor. So Moore's law is the exponential storage every year where you can store more in a smaller form factor. And then that is the birth of like cloud. So the 3 main cloud, I guess, services that people use nowadays is AWS for Amazon, Azure, Microsoft, Google Cloud Platform. I'm sure you used one of these in the past. And then this started machine learning and AI. So the creation of the ability to store more data in a smaller set is now giving us the opportunity to create newer things and more computational power to do greater things, which you guys have learned about today. So like blockchain, and I won't steal the thunder from any blockchain. I know there's a Web3 portion, but it's pretty huge right now as well. And then you have social media that we all use, advertising and marketing. These are probably my 2 favorite images in regards to data. The way I see data nowadays is it flows like water or air in our system, or money in the finance world. It's everywhere, and even in the places we don't see it. So even now I'm collecting data for Zoom. It's something that businesses now use to kind of get an idea of what their customers want without them actually telling them. And because of that, it's just floating around. All right. So with this is the advent of the term data mining. And this is the practice of analyzing large databases in order to generate new information. And when I say large databases, I don't just mean millions of rows, I mean trillions and maybe more. So this is an image, wheat to flour, but I was kind of hungry while creating this presentation, so I'll get more to the analogy later. So the types of big data we have. There's 3 main types of big data that float around in our system and cloud. A lot of them you've seen are more so structured, so your Excel spreadsheets, SQL tables, TXT files, things that are very human readable. Unstructured data would be things like logging, notifications, likes, volume controls, Twitter feed, whatever, things like that. And then semi-structured data is going to be like payment processing systems, where you have multiple categories of data, where you have like Visa, MasterCard, Capital One, but they all have the same general like category, which is this is a payment. So they're just formatted a little differently. Where's my mouse? Okay. So I guess in a visual, the unstructured data, structured data, this is kind of a unstructured data example. This is logging. So you'll see that the text is like timestamps. You'll see that there's like a little bit of text here, where it came from, but it is not usable to a report, right? You can't just have an import in just unstructured data. It needs to be cleaned, refined, and then turned into something similar to what you see here, structured data. This is a SQL table, so you have your headers, columns, rows, and indexes. And this is more usable to report. So the goal is to kind of convert what you see here to what you have there, and then create a view and a report to ingest it. All right.
Can we just clarify the name of this talk?
Yes, this is Demystifying the Art of Business Intelligence and Data Analytics. So in a nutshell, data mining plus computer science is the birth of data science. Data science and the birth plus recurrent neural networks is now what we know as machine learning. And then analogies and memes is optimized learning, in my opinion. So this is one of my favorite images. This is the elephant putting on a dinosaur onesie and becoming a data scientist. So with the rapid growth of technology, you're seeing a lot of more job titles and that people are unsure of. So data scientist versus data analyst, we have the same issue now with software developer versus engineer. And so the separation is kind of important because in larger companies, you want to make sure that there's a separation of concern and that people are focusing on what they're strong in. So I'm going to go over kind of what the differences are. So data scientists, by definition, design, construct new processes for data modeling and production using prototypes, algorithms, predictive models, and custom analysis. Sounds very math heavy, and it is. So normally, data scientists will have a PhD in some heavy math-related field or STEM-related field like computer science, algorithms, physics, and of that nature. And because of that, they get paid more. But very math-heavy, and you'll see why soon. Data analysts are more business-focused regarding like what is the business going to do with the data and what direction do they want to take next, right? So based off of the data that is cleaned, where should we do next? Should we offer this color for Teslas? Should we offer, this category on TikTok? So data analysts will examine the large data sets to identify trends, patterns, develop charts, create visual presentations to help business make more strategic decisions. Okay. So again, this is, hopefully you had breakfast, but this is kind of a food-related analogy. But has anybody seen the TV show Chopped on the Food Network? Okay, if you have not, it is a TV show on the Food Network where chefs compete in front of a panel of judges to create the best dish using pre-specified ingredients. So an example would be, my best analogy that I can give is Gordon Ramsay is your data analyst, and then your farmer is data scientist. So Gordon is taking the ingredients that he's given to kind of create a dish and then present it in front of usually a business side or whoever the consumer of that report or dashboard UI UX is going to be, and then hopefully it tastes good. A data scientist is an agriculture engineer, farmer, and they focus on like crop rotation, seasons, water, and how the ingredients are prepared. So like if it's going to be organic, gluten-free, non-GMO, and that gets put into the refrigerator for Gordon to use. So both are very needed when collecting data and aggregating data, but then also presenting it well and being able to make decisions on it is also very important too.
Not sharing the right screen. Okay.
All right, so this triangle is a pretty popular one. It's a data science hierarchy of needs. So normally data analysts will live in that box area in a large company where they do a lot of the simple machine learning algorithms, analytics, metrics, segments, aggregations. And in small mid-sized companies, data analysts perform mostly all tasks. And the small joke that I have about this, it's small business wants to hire someone to make decisions on their data. And so they're, someone asked, do you want a data scientist or a data analyst? And they say, which one's cheaper, right? Because, you know, in a small company, as you may know, you're oftentimes doing the full Monty, like the 1 through 100. So data analysts are more affordable for business, but when you scale up, you do need to have those two separate specialties. All right, so now we'll get into the actual reporting lifecycle and what I think are the 4 main components when starting a report or building anything for a business to consume. The first thing you're going to ask yourself, what are my data sources? So the data is going to be held, hopefully, under lock and key somewhere, and you'll need credentials, some sort of API key to access them. Could be one data source, hopefully, could be multiple data sources, but you will need some sort of connection string to access and that data, right? And data comes in all shapes and sizes. There's more than what I've listed, but there's XML, which is extensible markup language, JSON, JavaScript orientation, which is great for web technologies, CSVs, which is very common nowadays in SQL tables, databases, MySQL, Postgres, things like that. So these are going to be your data sets, right? So once you have access to the data source, you're going to get a extract of data, and these are going to be your tables, your payloads, and they will have data that you might not need. So the question is now, do we need to clean it or convert it? Do we need, and will this help us achieve our end product? So just on the data set that I see here, you may not need some of these, like middle name. You can probably get rid of that, name, style, and things of that nature. So there's once you receive the data sets you do want, you'll still need to do some filtering, maybe create a view, and just take the data that you need for the end product. Images is a bit blurry, but these are multiple tool sets that you can use. So on the right side, those are version control like Git. Inside the middle, you'll see like Tableau, Python, you see the Python symbol. But the next step of the third component is, what tools am I going to use? So once you have access to the data and which data you want to architect a solution that's scalable for your company. So which stack am I going to be using? Do the people have access to the report, and where will I be hosting it? And how is it going to look? So now we're getting more into the not so technical side, but more so like catering the final version to who's going to be actually using it. So this gets into UI and UX, look and feel. Who are my primary users? Do they have permissions to access this report? How will they be interfacing it with it? So kind of entwine with the last one. Which parameters should I have them be able to sort and filter on? And what kind of visualizations do I want to give? So this is an image of the endangered species list, and it's a pretty explanatory like image that shows which animals are endangered based off their silhouette and at which tier they are becoming endangered or not. Another one that I like is this beetles one. It's very clear to see, like writing percentage by album, you'll see that the writing responsibilities have distributed across more members in the Beatles over time. You'll see, except for Ringo, unfortunately, sorry Ringo. But George started writing more, and then John started giving more of the writing responsibility to Paul. And you'll see writing for the artists over time. So something like this, if you had parameters that would tweak the bar graphs, that would be amazing. And then kind of change that filter and maybe some color. But this would be a great way for a business to understand like, okay, where do we need to, adjust, and where do we need to move directionally in the future? Okay, so now for the tips and tricks. Again, with my food analogies, because pretty hungry still. But an experienced chef is comfortable in the kitchen because he or she understands the fundamentals and foundations. So these are understanding your technical skills, object-oriented programming, aggregate functions, relational databases, many-to-many. Be knowledgeable of the tools you have available and be creative. You'll always find a solution. I think that they underestimate how impossible it is to find a solution, but I think any solution is possible. There's actually a million ways to solve a problem as long as you have the right tools. And building visualizations or anything in IT is an 80-20 rule. So like cooking, the preparation process, which is like the peeling, the cutting, and all that prep work, that's 80%, and the actual cooking part is only maybe 20%. So I would really heavily stress to kind of architecturally build out and visualize what you're going to do before you execute. And this will save you a lot of headache and time and stress when you're doing the 20% of the work, which is the actual coding and going through what you need. So understanding the technical foundations, and I kind of touched on them earlier. So these are your aggregate functions. So in SQL, it's your sum, count, group, order by. When you're working with an API and using actual programming language, a lot of libraries will have these as well, like sort, count. Your object-oriented programming staples are, data members, attributes, classes, understanding those, maybe like protected, private, public, inheritance, and then relationships, many-to-many, one-to-many. What you'll see here is an ERD, an entity relationship diagram. So you'll see that like stores is connected to sales, and then sales connected to the titles of inventory, things like that. So everything is kind of related, and you'll see how to do the joins, how to bring them into a view, and then have exactly the view you need in order to take it in through to a dashboard. So some of the key takeaways. Well, I have a couple stories. Before the academy, I used to work at a ERP SaaS company where they did billing, accounting, project management, and software professional services. And I think what I learned out of my experience there was the biggest thing that they wanted was to find out how what their users wanted without them telling them. So it more so, how can we know what they want before they even know what they want? So like predictive analysis. So internally, would be building reports to save money, right? Cut costs, wage, salary comparison. Am I paying this person too much or too little? Profitability. And then externally, it'd be how to make more money. So this would be product pricing, markup on billing. Are we too short? Are we like undershorting ourselves on the contract, or are we too expensive? So little things like this are the helpful things that reports can do for you and what data analysts can provide for business. And every business needs someone like this. Okay, so the summarized comparison would be a data analyst is an individual who is responsible for bridging the gap of understanding between aggregated data and assists in building tools the business needs to make the best decisions. And in business intelligence is the logic, strategy, and industry-specific tools that allow the business to make sense of their own data and formulate decisions. So the data analyst, you're using business intelligence to build your product. Some helpful resources that I have. I used a lot of Shashank content for this. I think he's very thorough, and I'm not sure if you know him already, but for data science, data analytics, he's amazing. Link to Kaggle. I'm sure you've heard of Kaggle too, but they host data science competitions. And so as you get more advanced, you can definitely compete in those. And then Tableau, this is a article for visualization tips and things, but these are just normal documentation. You probably get that anywhere. All right, and my socials are below. Feel free to follow me on LinkedIn, Twitter, Instagram. That's the end of my presentation. So if you have any questions, please let me know. Thank you.
Question.
Yes. Okay.
The image you had in that one data set, what was that data from?
Oh, okay.
The one that had little name you're saying.
Yeah. So those are adventure works. Oh, he was asking me what the data set was from that I had in the slide. I can go back to it. So I stole this from Microsoft. They have like dummy data. So this is AdventureWorks. That's their like dummy company that they use. So you'll see all the emails have adventureworks.com. But yeah, you can really use any data set. So, but yes, it's from Microsoft. I'm a big Microsoft fan. So, any questions about? Oh yeah. Oh man, I don't want to like I don't want to steal anybody's thunder because there's a lot of speakers that have that. I think it's long-term viable for sure. We're seeing a lot of trial and error right now with it. So, but I don't think it's going away. Yeah. Oh yeah. So he asked, what do I think about Web 3.0? So this is like blockchain and crypto and all that stuff. And I think it's long-term viable for sure. So yeah.
Yeah, I have a question. Could you give any tips, maybe challenges, insight-based interfacing with non-technical management? You know, managers that perhaps don't have insight into.
Yeah, that is quite common. In an ideal situation, you want your manager to have that technical knowledge. It makes your job easier. But you know, often case the ideal situation is not common. So in a way, you're going to be the one guiding them. So help me to help you in a situation like that. So you want to make things very clear and kind of concise and break things down to simpler terms, and then maybe speak at their level. And yeah, but that's a very good question though. Yeah, it's a common thing for everyone to have that.
To see where GPU compute competency accelerating some data processing workload well, and do you consider that you look at that?
Yeah, so yeah, definitely since we're having so many large data sets, the computational power that's required is going to be much higher now. I even see a lot of companies where they have like just desktops that are very low spec desktops connected to internet, and then they actually have huge graphics cards in the back end that are running these cloud services, and then the desktop is just like the UI. So I definitely see that becoming more cost effective too, because you don't have to spec out all your computers. You can just have these little like tablet, small form factor things connected to a good Wi-Fi source. So yeah, that's definitely future for data mining too. Good question.
Well, thank you, Brandon.
All right.
Thank you so much for your time.
Thank you. Thank you, everyone.